We've seen two different types of neural networks at this point. Our first neural network learned to convert Celsius degrees to Fahrenheit, so it returned a single number that could be a wide range of floating point numbers. On the other hand, the neural network we saw in this lesson produced 10 probability numbers. The probabilities indicate how confident our neural network is that the given input image is of a particular class. So we can see that neural networks can be used to solve different kinds of problems. The first problem, where we predict a single number from an input, is known as a regression problem. Converting from Celsius to Fahrenheit is one example of a regression problem. Determining the price of a house, given its number of bedrooms, square footage, number of bathrooms, etc., is another example. On the other hand, the problem we saw in this lesson of being able to classify images of clothing is known as a classification problem. Given the input, the model will give as output a probability distribution specifying the confidence the input is of a certain class. In this lesson, we classified items of clothing. Later, we'll build a network that can take an image and tell whether it's a cat or a dog. And this is another example of a classification problem.
So let's summarize the difference between these two types of problems. For regression problems, the output is a number. The goal of this number is to be the best result given the input. So in regression problems, we are not trying to classify anything. We're just predicting a number that is the best fit to the data. For classification problems, we have an output consisting of a set of classes. This classifies some input, for example, an image, as a shirt or a sandal. The output in this case is always a probability distribution, so the sum of all output numbers corresponding to the classes will be 1 or 100%. The main takeaway point is that all of our machine learning models is one of these categories, a regression or a classification model. And the difference is if we want a number as a predicted result or probabilities across a set of classes.
So congratulations. You've just learned about two different kinds of neural networks. Get excited for our next lesson. You'll be learning all about CNNs and convolutional neural networks.